Hello everyone. Today we have discussed torque on an electric dipole in the class. Torque you have done in class 11th also. It is force into perpendicular distance. Let us consider uniform electric field. Let us consider uniform electric field because we will calculate torque on an electric dipole in uniform electric field. I am writing E vector as electric field. Now let us consider this is the uniform electric field. Let us consider a dipole is placed at an angle theta in this electric field. Now electric field always start from positive and they end up at negative. Now let us consider this is the dipole placed at an angle theta. So minus q plus q, two equal and opposite charges separated by small distance. Dipole moment, its direction is from minus q to plus q. So this is the direction of dipole moment. Now it is making an angle theta with electric field. So you will write, consider a dipole placed in uniform electric field at an angle theta. Then what is the force acting at this charge in electric field? This is negative charge. So negative will get a force towards positive thing. So this is the force acting on minus q. And this plus q charge, it will experience a force towards this direction because this is positive, it will get attracted towards the negative charge. How will we write expression for that force? We know that electric field is given by F vector over q. So force is given by q into E vector. So we'll write here just magnitude. Here force is q into E in this direction. Here force is q into E in this direction. So these are two equal and opposite forces acting on the dipole. Two equal and opposite forces will form a couple and hence a torque will act on the system. So how to calculate that torque? Torque will be force, either of the force, you will take either of the force into perpendicular distance between these forces. One force is acting in this line, means you can extend it up till here. Another force is acting along this line. So perpendicular distance between them is, I will draw a perpendicular here. This is the perpendicular distance. How will you find this perpendicular distance? Now this is a right angle triangle. Here is 2a, length of the dipole. See, this is perpendicular, this is hypotenuse. So we know perpendicular over hypotenuse, that is equal to sine theta. This right angle triangle, okay. So this will be 2a sine theta. See, this is the formula, na? Perpendicular over hypotenuse, that is 2a, is equal to sine of theta. So perpendicular you will calculate, it will be 2a sine theta. So this distance will be 2a sine theta. So torque acting on the dipole is given by force, you can write any of the force, into perpendicular distance 2a sine theta. So what is this q into 2a? This is dipole moment. So torque will be p e sine theta. So in vector form we can write it as torque vector is p vector cross with E vector, because p is a vector quantity, electric field is a vector quantity, and sine theta we have done in class 11th. AB sine theta is A cross B. So torque is P cross E. Okay, direction of torque is given by right hand screw rule. You will use your right hand. See, this is P is acting in this direction, electric field is here. I am drawing here, this is P. This is the direction of electric field. So torque will be given by P cross E. So you will curl your fingers like this, P cross E. So my thumb is pointing into the paper, so torque is acting into the paper. Okay, P cross E. So torque is acting into the paper. So like that you can find the direction of torque by right hand screw rule. And when the torque is maximum, when this sine theta is maximum. Maximum value of theta is, sine theta is at 90 degree because sine 90 is 1. So torque will be maximum when sine theta equals to 1. This implies theta is 90 degree. So you can show that position by this diagram. This is uniform electric field. You place the dipole perpendicular to it. Okay, minus q plus q. Now it is making angle 90 degree with the electric field. So in this case torque acting will be maximum. And when the torque acting will be minimum, that is 0 when theta is 0 degree or 180 degree. So we can show it like this. This is your uniform electric field. Either the dipole can be placed like this, minus q plus q, or this is the electric field and dipole minus q is here, plus q is here. So here in this case, dipole moment is this direction, minus q to plus q. Electric field is in same direction, so angle is 0 degree. Here angle is 180 degree. Electric field is here, but dipole moment is in opposite direction, so angle is 180 degree. So this is how we can find the torque. Remember the formula, torque equals to P vector cross with E vector or PE sine theta. And what is the net force acting on this dipole? See, this force is acting here towards left side. This force is acting towards right hand side. So net force will be 0 because they are equal but opposite. So net force is 0 because QE minus QE, net force is 0, but net torque will act on the dipole. Okay, so this is all about what we have done today.